Hi folks, this is my first video of system design series, and today I'll try to design URL shortener, example bit.ly, some site like that. Okay, um, I guess you all have a fair idea about it. Means what the bit.ly bitly application is. It is an application which basically takes a long URL and shorten it out, and with that shortened URL, anyone can access that long URL. Yeah, that's the main purpose of that site. So in today's video, we are going to design that only. It's high level design we are going to discuss. So to discuss high level design, we are going to follow uh, step by step process, and we'll follow some steps. That is, let me write it up. To design HLD, we'll first follow the requirements. What are the requirements? Requirement can be of two types. One is functional, and another is non-functional. Two types of requirement will first gather, and then we'll go on the uh, what the entities are, means what are the tables in database we required, or how we are going to store it in database. So entities we need. Third, we are going to design what APIs we are going to follow. So APIs we are going to follow. Let me, let me yeah, what APIs we are going to follow. And the fourth is what will be the data flow. Data flow. And this one is optional. Okay, means if it is clear, then means अगर हम data flow identify कर पा रहे हैं, then we don't have to deep dive here, else we'll be deep diving in this point as well. Fifth is high level design, and next is the we'll try to satisfy all the non-functional requirement. Okay, so in 5 step we are going to design what we are going to design bit.ly bit.ly we are going to design. Okay, so to design this, let's first gather the requirements. First, requirements. What are the requirements to build bitly? Means some feature of the bitly is to give shorten URL. That is one prime feature. The second is uh, you means that site needs to be redirected to the long URL. If someone tries to access short URL, then it should redirect it to the correct long URL. So within requirement, we have functional requirement. Functional requirement, first requirement is shorten URL. Shorten URL. Okay. The second requirement is if that is already shortened, we have to access the original URL. Access plus redirect to original URL. These are some stuff we need to follow. Okay. Next is if we have any shortened URL, we are going to support few more things. One is let's user decide what the shortened URL could be. Means और जो भी वो चाहता है वो select करने के लिए दे सकते हैं. So जैसे for me, I have created my resume like bit.ly slash Chandrakant underscore resume. If you'll try to access that out, you'll be getting my resume from there. So something like जैसा कि मैं एलियास डिसाइड कर पाया अपने लॉन्ग यूआरएल को similar feature will try to give. So the shorten URL feature should allow user to create alias. Then second is expiry time. Let user decide the expiry time of a short URL. So these are a few things which we are going to satisfy here. And how we are going to identify uh, thing if that requirement is functional requirement or non-functional requirement. Whenever it comes to user and ability to do something, means user can do this, user can do that, then that will by default fall into the category of functional requirement. But when it comes to system, means system should support something, or system can scale up to this point, or system manage something like if that are the requirements, then it will be surely a non-functional requirement. Let me write non-functional requirement as well. Non-functional requirement. Not what could be the non-functional requirement? Non-functional requirement can be system जो है fast होना चाहिए. It should have low latency. That is one non-functional requirement, right? So let me write here a low latency. Let's say 200 milliseconds on redirection. When that short URL is getting converted to long URL and it's hitting original URL. At that time, it should be fast enough, else it will be keep on loading or user need to wait. That will not create a good experience for user. So one example is that we need low latency in our application. Okay, we uh, the second requirement could be our system should handle can handle 100 million daily active user. Let's write that as well. Means system can handle 100 million daily active user. See, system should support around 1 billion short URL. System should support how much? 1 billion. 1 billion URLs. Okay. So now we have functional and non-functional requirement. And here let's talk about capture a bit. In distributed system, we can guarantee either uh, consistency and partition tolerance or availability and partition tolerance. But means हाँ बस यही दो तीसरा केस पॉसिबल नहीं है that is hypothetical that you can guarantee consistency and availability but not partition tolerance. That is hypothetical situation. So in this system, if we see uh, we need our system to be highly available and eventual consistency will work for us, right? So let me write here the D point that we need high availability, comma, eventual consistency. Okay, so let's read what the hell is going on here. Okay, now it's visible, right? So we have a functional requirement of two types. One is functional requirement, another is non-functional requirement, and we are going to support this out. Now, the first thing is clear. Second, what will be the second stuff? Second thing will be, let's go back. What is the second thing? Entities. Okay, so what will be database or tables or yeah, we need to decide schema or entities right now. Entities. Okay, entities can be one we need is URL database. Okay, B we need is user database. Okay, and inside that URL database we need some column. We'll decide later and when we'll first create what will be the APIs for our system. On the basis of that API, we are going to populate this entities. Okay, so the third is APIs. What APIs our system should support? The first API is shorten URL. Okay, so URL shortener needs to be a post API. Why? Because means any user going to share what the alias is. If not alias, he need to share long URL. That is mandatory, not optional. And alias is optional, and we can ask for expiry time as well, right? So expiry time will also be optional. So let's write that API that is post API, and we need an short URL something endpoint, and that URL will return us short URL, and that will be string. Okay. Now, what will be the body? Original URL, it will be string. Okay. Next, alias. This will string, comma, optional, exp time. Third is exp time. This will be also string or date or some time. Let's take string from user. Okay, means uh, how many minutes or yeah minutes we can take or hours. We'll decide later what we have to take. But the thing is, we can take expiry time as well, and this is also optional. Okay. So now we have one URL. The next is redirect. So one should hit with short URL and that will redirect to long URL. So what user need to pass? The user need to hit the short URL, nothing else, right? So get API can work. Sorry, command Z. Get API will work, and that will be redirect. Okay, redirect API or here you can say, uh, yeah, the redirect URL will be here, and we don't need such any permission to pass. Okay, and it will redirect to original URL. Okay, let's see what we have studied right now. So to design any HLD, these are the steps we are going to follow. And right now we are designing Bitley, and the requirements are shorten URL and redirect. Okay, the non-functional requirement are that it should be low latency, and system can handle 100 million DAU, and 1 billion URL it should support, and high availability we want, and eventual consistency is okay for us. Next is what will be the entities. Entities will be the URL entity, and another is user entity. Okay, these are enough as of now. Later on, we'll uh, add if something required. Okay, so looking on to the APIs, we have short URL API that will have original URL, alias, expiry time, and next is redirect URL. That in that redirect URL, we'll be getting the short URL. On the basis of that, we'll be redirecting it to the original long URL. Okay, so this much is clear. Now, if these are the APIs, okay, then what would be the columns or things we require to save in database? Okay, let's analyze right now. And if we won't be able to get, we'll go ahead and then we'll try to analyze. As of now, in short URL, we know that short URL will be the key. Short URL, it will be the key. Next is long URL, long URL. Third is exp time. What else? Which user? User ID. Okay, for user ID. I think these are enough right now. We can add extra if required. Okay, so this is the thing which we have developed right now. Let's get back to our data flow. Data flow will be user to our system to our DB will return it to user. Okay, so these will be the data flow. Okay, let's design HLD of it. Fifth is high level design. Okay, so what we need in high level design, user we want. Okay, now we have user. What next? Our system. Okay, and next is our DB. So what user is going to do? User is going to request slash short URL. Okay, some logic will be there. URL shortener. Okay, and that will somehow solve the system, means solve the problem and store it in our DB. Okay, and it will provide us a short key. Short key. Store long URL. Okay, store long URL and provides short URL, and that short URL will be passing it to user. That is one flow. Okay, what next? The user will call redirect API, redirect endpoint, and redirect service we have that will go to DB, fetch the long URL, fetch long URL, and redirect that URL, not to user. Yeah, but the thing is, it will redirect to original endpoint. Redirect to original endpoint. Okay, that is clear. Now, there are one more thing that if you are redirecting, then the status code will be either 301 or 302. This is permanent and this is temporary. Means this will permanently redirect to that particular site and won't be able to get enough डेटा और कुछ ऐसी चीज होते हैं जो अ, हमारा जो वेबसाइट है वो कलेक्ट नहीं कर पाएगा बट इन 302 द थिंग इज अगर वो ओरिजिनल यूआरएल पे रीडायरेक्ट करता है एंड समथिंग फेल्स तो उसके लॉग्स वी कैन रिकॉर्ड okay so we can use either 301 or 302 301 will be cost efficient because analytical data we are not going to store but in case of 302 we are storing analytical data so it will be having some cost but that is good for our system that we can analyze that out and enhance our system with it okay so this is means what we draw right now is a high level design that we are going to follow okay let me try to draw it in some better way so that uh, you guys feel good okay user and then our system can we decrease it here and then next is db okay let's design db over here and that will be two-way it here redirect short URL okay this will be our high level design now we have to satisfy all the functional requirement and next we need to check whether this high level design can satisfy all the functional requirement or not if it can satisfy functional requirement we'll move to non-functional requirement okay so let me go to functional requirement functional requirement is a it should short url if we provide alias okay this url shortener can provide alias and expiry time as well next is access or redirect to original URL. Okay, this is pretty much we are going to do. And now let's keep on satisfying the non-functional requirement. When we'll go to the non-functional requirement, then at the time we will be needing all the fancy stuff like API gateway, load balancer, and number of concurrent server, how we are going to uh, means, handle 1 billion URLs. That will all come into non-functional requirement. So till now we have built an intuition and high-level design that we are going to uh, मतलब जो हम यूज करने वाले हैं राइट चलो तो अब हम चाहते हैं कि हाउ वी आर गोइंग टू बिल्ड नॉन फंक्शनल हाउ वी आर गोइंग टू सेटिस्फाई नॉन फंक्शनल रिक्वायरमेंट ओके scroll back to content HLD LLD and let's say high level design the let's go to the design here and now we are going to satisfy few requirements what are they uh, what will be the length of short URL we are going to provide let's assume around 5 to 7 or 5 to 8 let length of short URL 5 to 8 let's say okay 5 to 8 length we are going to satisfy if we are going to satisfy 5 to 8 length URL then what logic we are going to use first is let's use digits if we'll use digit then and length of short URL be 8 if it will be 8 then what 0 to 9 numbers we have, and we have 8 places like that. Okay, so 10 to the power 8, 10 to the power 6 is equal to 1 million. 1 billion is equal to 10 to the power 9. So this will not satisfy our use. Okay, so what to do? Let's use base 62 number, NUMBR number. Base 62 number. What is base 62 number? Base 62 number means 0 to 9 digits, A to Z character, and caps A to caps Z character. This is 10 plus 26 plus 26 is equal to 60 plus 2, 62. It will be 62, right? 20, 20, 40, 50, 50 plus 12, 62. So if we have 8 length and 62 possibilities for each, okay, each position, 62 values. So 62 power 8. How we need to calculate means how it will be. Uh, 62 means that will be enough to handle the 1 billion URLs, right? So we are going to keep base 62 uh, number to shorten URL. But the thing is how we are going to short that URL. Are we going to use one by one possible number or next possible character? And if we'll use that, that can be easily catchable or easily identifiable by hackers. So that will compromise our security. So what else we can do? Plus, the thing is, if we are going to use this number, then collision will be a problem. Means if we are going to use modular hashing, then also the collision will be the problem. So what else we can think? Uh, let's use something called MD5 hashing technique. Let's try what happen if we have long URL. We'll pass it to MD5 long URL. It will generate a hash. Let's take hash का 0 से 8 character. But still there will be chances of the collision. So to handle that out, I know one solution, that is D option, that we can map, we can use bijective function. Bijective function. Bijective function is something which is used for one-on-one mapping in math. So there are some providers which provide bijective function feature, and one short URL can map to one long URL. That will satisfy uh, our requirement. Means let's get back to requirement again and see how and how much or what we have built. So the functional requirement we already covered. Next is non-functional requirement. Now we are able to support 1 billion URL, right? Our aim should be low latency on redirection. So what we should do to get low latency? The thing is, let's get back to the design here. And if you see that user is trying to hit redirect, and redirect is at the end going to DB. What if we introduce a caching here? And in caching, we'll be using eviction policy as least recently used. Means the one which is getting highly used will store that in cache for a long time. Okay. So if we introduce cache over there, then it will be much faster. Means it will come to us. We will redirect it to the required original URL. So let me build something like that. Means here only can we change. I'll design the new HLD or new diagram, but right now let's use cache here. Cache, Redis cache. Redis are distributed cache, and that can handle mm, means too much request and with, without going down. So yeah, we can introduce cache that will hold long URLs, and that will redirect. Okay, so we have satisfied few conditions. Let's go back to our requirement and check what are we. Means we have used cache for low latency. We have used some bijective function for one-one mapping and used base 62 numbers. so that we can satisfy 1 billion user as well. Okay, and it should be highly available and eventual consistency. So what we are going to do is we'll talk about this at last. And at this point, let's talk about high availability and eventual consistency. If we see uh, to be our system highly available, eventual consistency, what we can do is we can directly write to our DB and then update it to cache. Okay, Hmm. that we can do, and this cache returns the short URL means hmm, that will use. Okay, so now why it is highly available but low consistent? Because when somebody tries to create short URL, that short URL will be created. Okay, and if we try to access that short URL, means there is a chance that we previously might have used that short URL for something else, as we have expiration time and alias. So we can assume that we might have using that short URL again. Okay, so at that time, let's say some user wants to access uh, something with that particular short URL, and in cache that short URL is mapped to another long URL. Okay, in that case, our system will redirect it to older URL rather than redirecting it to the new URL. So here we are compromising consistency, but that is eventual, not for permanent. Over the time, that system will handle that out. Okay, so let's get back to requirement again and see how much we have satisfied. Till this point, we have three non-functional requirement and we have satisfied it. What if there will be 100 million daily active user? Then how our system is going to handle it? So to handle that out, our system need something like load balancer and API gateways that interact with user. Okay, what else we can enhance? The thing we can enhance this part to two chunks. Means we can create microservice. Okay, one microservice for shortener. Second is for redirects. One is basically writing in DB. One is just reading. So we can have two microservices for that. Okay. So how the design will look like if we have that stuff, then design will look like something like this. Let's have user, and that user is going to interact with load balancer, and that load balancer is going to interact with API gateway, and API gateway will be interacting with multiple services. Okay, and let me try to move this a little bit. Okay, so we have this. What else we need? Oh, sorry, I moved my camera a bit. Okay, what else we need? That user is interacting with DB as well. Okay, this is our DB, and we need caching. We are going to use cache as well. Okay, now let me write user LB and AG redirect service. This is shortener URL shortener. Okay, this least recently used eviction policy DB. Okay, now let user interact short URL, and then short URL will interact with the API gateway, and that will interact with shortener and that will interact with Redis, and this will also interact with Redis. Okay, now this will be high level architecture that we are going to follow over here. Now the next question is, what if there are more servers required? Then we are going to just 1, 2, 3 scale these servers if that is required. Redirects required, we are going to redirect this 1, 2, 3 and so on. So this will be, let me zoom it a bit. अरे हो जा भाई, ठीक है। तो ये हमारा हाई लेवल डिजाइन होगा हमारे URL शॉर्टनर का। एंड to check if that is correct or not, what we are going to do is we are going to check this. If uh, we are able to satisfy shorten URL and redirect stuff, we are able to handle this 100 million daily active user, 1 billion URLs we are supporting, and high availability and eventual consistency. So at the end, we are able to satisfy all the requirements. So I think, as per my knowledge, this design is enough. In our next lecture, we are going to discuss something similar problem, and if possible, I'll try to create one class diagram or LLD for this topic. Right now, it's too long, and I'm stopping this.